Hi guys, good morning and welcome you once again in a new session of solid state chemistry. In our last video, we study about the defects or imperfection in solid and type of defects we have studied. Kindly go through the NCERT and go through the distance between two words because it helps you enrich your knowledge. If you read a book once, twice or thrice, each and every time you've got a new information from your textbook. So in our last class we discussed imperfection or defects. Here I'm just trying to understand the imperfection or defects in terms of flow chart, in a form of a flow chart. So here it is. Impurity or defects. Imperfection. Imperfection. Crystal defects. Crystal defects are of two types. Point defects or line defects. Point defects further classified into two group, which is stoichiometry defects or non-stoichiometric defects. It means stoichiometric defects, non-stoichiometric defects. Metric defects. Stoichiometric defects further classified in the following type: vacancy defect, vacancy defects, interstitial defects, interstitial defects, Schottky defects, SCHOTT keyword, Schottky defects, and Frankel defect. Non-stoichiometric defects are two types: metal excess defect or metal deficiency defect. Metal excess defects further classified as vacancies, absented, metal excess defect due to interstitial vacancy, interstitial vacancy. Metal excess defect due to interstitial cation. Interstitial due to interstitial cation. So this is the flow chart. With the help of it, we are able to understand the crystal defects. Today, we are going to discuss about the type of solids on the basis of electrical conductivity. On the basis of electrical conductivity, solids are three types: conductor, semiconductor, and insulator. Conductor: the solid which permit maximum flow of electricity is known as conductor. And the conductors, your conductivity order 10 raised to the power 4 to 10 to the power 7. 10 raised to the power 4 to 10 to the power 7. Ohm inverse, meter inverse. In metal, conduction takes place due to electron, while the ionic solid due to ion. All the metal in aqueous solution of, for example, all the metals or aqueous solution of NaCl are conductors, semiconductors. Solids which permit less flow of electricity as compared to the conductor known as semiconductor. Its conductivity range is 10 raised to the power minus 6 to 10 raised to the power 4 ohm inverse, meter inverse. As the temperature rise, their conductivity value also rise, because electron from the valence bond jump to conduction band. For example, silicon, germanium. And the last one is insulator. The solid which are unable to conduct electricity are known as insulator. Their conductivity value range is 10 to the power minus 20 to 10 to the power minus 10. For example, sulfur, phosphorus, and other nonmetals. To understanding the conductivity, we'll go through the bond theory. What is bond theory? Bond theory explains the conductivity of conductors, insulators, and semiconductors. The interaction between the valence bond and conduction bond is decided conductivity of a particular material. If the energy gap between two cells is negligible, the electron can jump easily from valence cell to conduction band, valence band to conduction band. It means substance behave as a good conductor. When the energy gap is small, the electron jump from valence band to conduction band, on providing little energy. This type of solids behave as a conductor and called semiconductor. And if the gap is large enough for the electron to excite themselves from valence band to conduction band, they act as a insulator. So understanding the band theory, we may draw the following small diagram to understand the bond theory and how the substance get conducted, how the substance get excited, how the bonding between metal substance or solid substance behave in this. This is the band theory. Band theory. Conductor, semiconductor, insulators. Insulators. Conductors. Conductivity range already we have stated 10 raised to the power 4 to 10 raised to the power 4 to 10 raised to the power 7 ohm inverse meter inverse is the unit. Its value is 10 raised to the power -6 to 10 raised to the power 4 ohm inverse meter inverse, and its conductivity range is 10 raised to the power -20 to 10 to the power -10 ohm inverse meter inverse. So this is what the conductivity range, and substance behave like a conductor, insulator or semiconductor. Now in case of band theory, if this is the band, it means electron easily transmit from one layer to another layer. There is a superimposition between them, is conductor. This one is CB conduction band, this one is VB valence band. In case of semiconductor, the gap is small. It means on providing the energy, VB valence band, CB conduction band, the gap is small, so electron may excite to reach the higher energy level, and resulting in what? Here is the gap is too small. Gap is too small. So this become like this, and this one become what? Closer to each other. But in case of insulator, the gap between valence band and conduction band, VC and VB valence band and CB conduction band, is very large gap. So electron cannot jump from one energy level to another energy level. So this is the summary of understanding by drafting the diagram to understand the band theory. Let's move. The next point is doping. You know that doping means, the term doping is very much familiar with us. Doping means addition of any impurity, any insertion is called doping. Whenever we mixed a foreign particle, another substance that are not the constituent of that very crystal originally, but on addition any external substance, mixing of impurity in a solid crystal is known as doping. Doping. Mixing of impurities in a solid crystal, in a solid crystal. In any solid crystal, if we add some impurity, it is called doping. Doping by doping conductivity of semiconductors can increase, can increase, or can be increased, can be increased. Increased. The number of electron or cation vacancy can be increased because the number of cation or anions vacancy can be increased by doping. By doping. On the basis of doping, semiconductor become two type, n-type semiconductor and p-type semiconductor. Now n-type semiconductors. N-type semiconductors. Group 14 doped with group 15 elements. Group 14 doped with group 15 elements. For example, doping of phosphorus in silicon. phosphorus in silicon. Silicon has 4 valence electron and phosphorus has 5 valence electron. When silicon is doped with this 5 valence electron, 1 electron become more and substance behave like a conductors, and this is increment of the conductivity of n-type. Now we move towards the p-type semiconductor. When group p-type semiconductor, p-type semiconductors, group 14 doped with group 13 element. For example, doping of boron in silicon. Valence and electron. In case of boron, there are 3 electron valence cell. In case of silicon, there are 4 electron. So when group 13 element is doped with 14 group element is doped with 13 group element, one more electron come in this case, and that makes it a conductor. So this is the doping. Now solid substance classified on the basis of their magnetic properties too. So the classification based on the substance on the basis of magnetic properties, we are going to study about that. I hope you all noted down this to understand the doping or intermixing or addition of impurity. So let's move towards the type of solid on the basis of their magnetic properties. To understand this, we just draw a flow chart. Classification of substance on the basis of magnetic properties. Classification of substance on the basis of magnetic properties. On the basis of magnetic properties, substances are classified as paramagnetic, second one is diamagnetic, third one is ferromagnetic, fourth one is antiferromagnetic, and the last one is ferrimagnetic. Paramagnetic substance. The substance which are attacked in external magnetic field, attracted. The substance which are attracted in external magnetic field called paramagnetic substance. And property is called paramagnetism. In external magnetic field, the substance which are attracted in external magnetic field are known as paramagnetic substance. In such type of substance, atoms or molecules have some unpaired electron in magnetic field. The alignment of magnetic moment develops magnetic property. Thus, substance acquire temporary magnetism in the magnetic field. For example, Cu2 plus O2, etc. Diamagnetic substance. The substance which are repelled in magnetic field are known as diamagnetic substance. The atom or molecule of this substance have paired electron only. For example, zinc, TiO2, NaCl, etc. Ferrimagnetic substance. The substance which are attracted most easily in magnetic field are known as ferromagnetic substance. These compounds acquire permanent alignment of magnetic moment in magnetic field. For example, Fe, Co, Ni and CrO2, etc. These are the ferromagnetic substance. Antiferromagnetic substance. Those paramagnetic substance whose resultant magnetic moment due to alignment of magnetic moment in the magnetic field is zero. It means the alignment of magnetic domain is anti-parallel to each other. And the next one is, for example, MnO, alignment of magnetic moment found opposite to each other and equal number. So the net magnetic moment get cancelled with each other. And last one is the paramagnetic substance. It's a ferrimagnetic substance. Ferrimagnetic substance involves resultant magnetic moment due to the alignment of substance in such magnetic field less than that of the ferromagnetic substance are known as ferrimagnetic substance. In such substance, magnetic moment aligned in parallel way is more than the opposite side. It means alternate alignment. Here I am just trying to draw some alignment of the magnetic moment to understand how the electron or the magnetic domain get aligned. So first of all, in these three cases, ferromagnetic substance, antiferromagnetic substance and ferrimagnetic substance, I am just trying to draw a diagram to show these how these are relevant. Magnetic domains are aligned in a single direction. This is what ferromagnetic substance. In case of antiferromagnetic substance, the alignment of the magnetic domain become anti-parallel. It means one is up, second one is down, another one is up, second one is down, another one is up, second one is down. This is the anti-parallel. Anti-parallel means one domain is up, second is down. So the net magnetic moment, this case become zero and the substance behave like an anti-magnetic substance. In case of ferromagnetic substance, what happens? Anti-parallel. Parallel and anti-parallel. If the domain is, two domain is up and one domain is down, next again two domain is up, one domain is down, two domain is up. In this way, what we observed, these two, if I am considering this, two domains are cancelled out, but the next domain is in the same directions. It means what? This will raise the magnetic properties in this substance and the behave as a ferrimagnetic substance. So in this chapter, all the topics we have covered in this video, and I hope you all learn a lot. But before closing comments, I just want to say that kindly focus your NCERT book and go through that. If you have any problem, any kind of difficulties while studying, let me inform through the proper channel. It means your WhatsApp group.